Full wave rectifier. In the half wave rectifier, the input voltage is used only in one half of the cycle, and also it reduces twice the exposure time. Therefore, there is a need for a rectifier which will use the full cycle of the input. This is possible by having two or more number of diodes. The alternative voltage is applied between A and B as usual. Then the output is obtained across the resistor R. So we are using full wave rectifier to use the full cycle of the input voltage, and exposure time is reduced to half. Let's discuss the mechanism in the upcoming slide. The full wave rectifier used with the rotating anode X-ray tubes. It produces 100 X-ray pulses per second compared to half wave rectifier. In full wave rectifier, we use one or more diodes, which are D1, D2, D3 and D4, which converts alternative current into direct current, where the alternative current which simultaneously changes its direction. In half wave rectifier, we obtain only half of the cycle. So, in order to obtain the full half of the full cycle, we use full wave rectifier, where the input voltage was applied by the source to A and B. Then the output was obtained in the resistor R. When A is positive, the D1 and D4 will conduct and a current flows through R. During the half cycle, during the next half cycle, A is negative and end B is positive. Now, the diodes D2 and D3 will conduct and a current flows through R as a direct current. Then the next half cycle was completed. Thus, the current flows through the resistance R during full cycle of the input voltage in the same direction. The X-rays are produced in 2 pulses per cycle, irrespective of the polarity of the transformer. 3-phase generator employs multiple rectifiers in the secondary circuit. Full wave rectifiers are used in I and end X-ray tubes, which implies rotating anode X-ray tubes. So compared to half wave rectifier, the full wave rectifier produces a full cycle in half of the exposure time, and also it gives 100 X-ray pulses per second.